Good morning. So I know we've never done video notes together before. This is kind of what it's like. So I'm here by the document camera recording myself. You guys have the notes in front of you. You, just as normal, write down everything that I write on here on your sheet, okay? I'm going to actually start on the back, just so you don't have to go back and get your notes from the other day. I'm going to start on the back, and I know we didn't get a chance to do 11, 12, or 13, but hopefully when you guys did the homework, you practiced, you felt good. What I want to do is practice 14, 15, and 16. And what we're going to do in these problems is we're going to write an equation of the graph shown. And again, this is just the last page of your notes, but I recopied it for you. It says that on the top. When we write an equation of the graph shown, you guys, we're going to want it in this form: y equals a times the absolute value of x minus h plus k. And again, the important thing to remember is that, remember, the hk part is your vertex. Remember, we find the vertex by what's on the inside and the term on the outside. And then basically the a value is going to tell us the opening and our slopes. So a tells us the slope, and how it opens. Okay? So if I look at number 14, let's first identify the vertex. Our vertex in number 14 is -1, 2. So that means when I write my equation, I have these 3 spots that I could potentially put things in. Remember, the x-coordinate of the vertex goes inside, and we said it's the opposite of what we see. So since we saw -1, this means that inside the absolute value, we'll want to see x plus 1. The y part of the vertex is the term on the outside. That has the same sign as what we see, so that's going to be +2. Okay? So what about this guy? Well, this guy we get by looking at the slope. If we look at our slope, and you can use either one that you want, but a lot of times it's nice to start at the vertex and go from left to right. Notice that our rise over run is +1 over +1. And that just gives us 1. So that means that we could put a 1 here. But remember, this is multiplication. We don't really have to put a multiplication by 1. So that's our answer. Y equals the absolute value of x plus 1 plus 2. Let's do the same thing in number 15. First, let's identify our vertex. Our vertex is at +2, 3. So that means in our equation, this +2, bring this up a little, sorry. This +2 tells us about what's on the inside here. Remember, the x-coordinate is the opposite of what we see. The y-coordinate is the same sign of the term on the outside, +3. Now we need to see if there's something that goes in front. And so we look at the slope. And if I look at my rise over run, it looks like my slope here is down 2 over 1. Now notice on this side it's up 2 over 1. So we know there's going to be a 2 here for our slope. However, notice that the V shape opens down, which means there's a reflection in the x-axis, and since it opens down, we want to make sure that's a -2. And that's our equation. So it's really just going backwards from what we did together last time. Last time we had an equation and we put the graph. Now we're just taking the graph and making the equation. Let's look at 16. Our vertex in 16 is -2, -3. Make sure when you write your function, we want y equals. And then our vertex tells us the term that goes inside the absolute value with the x, opposite of what we see, so +2. And on the outside, it's the same sign as what we see, -3. Now let's try to find this value here. If we look, we're going down 1 over 2, or up 1 over 2. So notice that we have a slope of ±1/2, but because it's opening upward, when we put that 1/2, we'll keep it positive. And that's the equation. So that's not bad, right? So now that we've written the equation with the graphs, let's write equations from tables. And I have some steps for you on the front. The first thing we're going to do is we're going to look for the vertex in the table. We're going to do that by looking for symmetry in the table. And so symmetry is when it's the same on both sides, okay? It's not always going to be the middle of your table, but symmetry means that things look the same as you go on the other sides. We talked about that in the family of functions. And let's circle our vertex. So in example 1, we look to see where are there symmetry in the y values. And do you see that right here with this 2, that as we go to the right and to the left, that there's symmetry, it's the same thing. So that means that this is our vertex. And what that means that when we write our equation, remember that the vertex fills this part in. The x-coordinate is the opposite of the x we see, and the y-coordinate is the same in the equation. So how in the heck are we supposed to get this guy? Well, let's look at step 2. Step 2 says find the rate of change by looking at change in y over change in x in the table. Okay? And when we do that, I want us to start at the vertex. So I want us to start at the vertex and work to the right. That will ensure, you guys, that we get the correct sign, positive or negative. Okay, so we're going to start at the vertex we found, and let's look at our change in y. Notice our y is going up 2. So for our change in y over change in x here, I'll write that we're going up 2 for our change in y. For our change in x, notice we're going up 1. And then we simplify. Positive 2 over positive 1 is 2. And so that's the value that we put as our multiplier in the equation. And that's how we can write an equation from a table. Let's do a couple more. Example 2. Notice the middle of our table doesn't have symmetry. You see how if we look at 4, 3 and 5 are not the same. We want to try to find, when we look on both sides of the number that we have the same number. Notice that happens here at -2, 5. This is our vertex. And again, if you would like, we can right away put the vertex in our equation. The x-coordinate is the opposite of what we see in the equation. So since the x-coordinate of our vertex is -2, our equation will involve the absolute value of x plus 2. The y-coordinate is 5. That stays the same. Now we need to work on the a value. And we do that by the change in y over the change in x. Let's start at the vertex and work to the right. Notice we're going down 1, down 1. So our change in y is -1. Let's look at our change in x. Our change in x is +1. And what does -1 over +1 turn into? Well, -1. So that's what goes here, -1. And if you want, to be honest, you don't even need the 1. You could just put a negative symbol. That means there's a reflection, but no vertical stretch or shrink. But that's our equation. That's the gist of it, guys. Let's look at example 3. We'll do 2 more, and then I'll let you work on your worksheet. In example 3, where is there symmetry in the table? Where do you see y values that are the same on either side? And hopefully you see that here, that it's mirrored, the y values are mirrored as we look on both sides. This is our vertex. And remember, we can place that vertex in the equation. Maybe we'll wait for this one and put it all in at the end. Now we want to find our change in y over change in x. Notice that our change in y is that we're going up by 2 each time. But our change in x, we see that we're going up by 3 each time. So our change in y was +2. Our change in x was +3. That just reduces to +2 over 3. So if you're writing your equation, which number would come first in front of the absolute value symbols? Well, it's that change in y over change in x, +2/3. Inside our absolute value symbol, don't forget our x, and we look at the x-coordinate of our vertex, and since it's +8, we see the absolute value of x minus 8. The y-coordinate is the final term of our equation. And that's it. One more, example 4. Where do you see symmetry? I see it right away here with 1, 0. Here's our vertex. And now let's look to see the change in y over change in x. My y is going up by 5 pretty consistently. So I can make a note that my change in y over change in x, the change in y is +5. My change in x, let's see, +1 each time. And so my change in y over change in x is 5. So if I'm writing my function, I need a y equals, or f of x equals, g of x equals, whatever. And then remember the rate of change goes here, +5, since we started at the vertex and it was increasing from left to right, times the absolute value of x minus 1. And then the 0 would go on the outside. Do we need to write plus 0? Not really. And then that's our final answer. So that's how you can write equations from tables. Now I'm going to be honest, writing equations from tables isn't on the worksheet y'all are doing in class today, but writing equations from graphs is, as well as comparing with RST like we did yesterday. Remember, anytime it says to compare, that's when you do RST. And then just graphing the functions and stating the domain and range like we did yesterday. Okay, so you may get out those notes, use these notes to help, and good luck on your worksheet. We'll see you tomorrow. Thanks, guys. Please work well.